The objective of this experiment is to study the conduction of heat transfer between glass rod and metal stick.
Heat is energy transferred from one object to another because of a difference in temperature. Heat is transferred in three ways: by conduction, convection, and radiation. Conduction is the process of heat transfer from hot to cold, which requires contact. Convection is the process of heat transfer through the movement of particles like liquid or gas. And radiation is the process of heat transfer through electromagnetic wave and doesn't require any medium.
The materials we use in this experiment is metal stick, glass rod, marshmallow, candle, matches, and stopwatch.
So from the experiment, we can see that the marshmallow on the glass rod took longer to melt than the marshmallow on the metal rod.
Why did this happen? Glass is typical of solids in the way it conducts. The particles that are close to the fire begin to absorb heat from it and vibrate more vigorously. The energy is then passed along the rows as they collide with the particles next to them. Each particle vibrates faster and more vigorously, transmitting heat from one to the next through the collision, causing the particle to move slowly through the glass. This is how conduction happens and why solids are so good at it is because the particles are so close together that they collide very often.
Compared to glass, metal is such an incredible conductor. The same thing is happening here as in the glass. Near the fire, the atoms gather heat, vibrate, and collide with the one next to it. However, different from the glass, there are electrons whizzing around inside the metals, which are known as free delocalized electrons. They can collide with all of the ions in the metal, gaining heat from the hot end and rising straight down to collide with an atom at the cold end. As a result, the heat spreads through the metal much more quickly than the glass.
The equation we use in this experiment is the rate of heat flow, delta Q over delta T equal to Ka delta T over L, which delta Q over delta T is the rate of heat flow, K is the thermal conductivity, A is the cross-sectional area, delta T is difference in temperature, and L is the distance between two ends. The rate of heat flow is directly proportional to the thermal conductivity. So the higher thermal conductivity, the higher the rate of heat flow. So how well objects transfer energy by conduction is known as thermal conductivity. By this equation, we can prove that metal has higher thermal conductivity than the glass. That's why the marshmallow on the metal stick melt quickly than the marshmallow on the glass rod.
So in conclusion, conduction, radiation, and convection are the different ways heat can move through a system. Second, the thermal conductivity of a material is a measure of how quickly energy transfer through it by heating. A material with a high thermal conductivity transfer energy quickly. A material with a low thermal conductivity transfer energy slowly and may be used as a thermal insulator. That's all from us. Thank you.